with our eyes if needed. We're going to put those solar glasses back on, of course. And the crowd just erupting, falling quiet again as they watch this magnificent moment take place.
I am actually seeing bats flitting through the air.
Oh, wow. Well, we will be very careful then.
Well, yeah.
And why is that, Patrick? Again, those nocturnal animals are coming out, right?
As far as they're concerned, it's nighttime. It's time to feed. So they're coming out to feed on all the mosquitoes we've been swatting.
Okay, got it. We'll be very careful for all those nocturnal critters around us right now.
All right. We are getting closer. Get ready to put those glasses back on.
All right. We're putting those glasses back on. The crowd is, wow, a second diamond ring seen from right here in Arkansas, the Diamond State. Absolutely stunning.
Outstanding.
Beautiful. Patrick, we're going to turn around now and just one question I really do have to ask you before we let you go is, are you Team Sun, Moon, or Earth?
I am Team Sun. Team Sun all day long.
Fantastic. I figured from a heliophysics expert like you. We want to thank the city of Russellville for hosting us, Arkansas Tech University, and our telescope feed operator, Joe Mattis. Thank you so much. Now, let's get back to James Traley over at Kennedy Space Center. James, back to you.
Yeah, thanks so much, Jasmine. What have you guys had there? So you were just right here in Russellville. You can see that shadow has now officially moved off and is on our way to our next target, which is up here in Carbondale. Carbondale is one of those very lucky cities because back in 2017, they were right at that intersection point of the 2017 eclipse across America. They're there again this year, but the difference is they're going to have a much longer slot. In 2017, they only had 2 minutes, 40 seconds, and that's not as much as they're going to have this year, which is 4 minutes and 10 seconds in the totally eclipsed sun. A really great viewing window for them to really take in this big moment. Very exciting to be able to track that for them as well. And also some details about this tool here as well. If I click onto their eclipse time here of 1:59:15 local time, you notice this little icon comes up here. This is actually simulated based off real data from the Parker Solar Probe of what we expect the corona around the sun to look like. And as you just heard, the sun's a lot more active this time around. It's kind of like a wild hairball, if you will. Lots of different streamers and things streaking off the sun. So you've been seeing already in our coverage some really cool activity around that sun's corona. If you're really lucky and the timing is just right, you might get a coronal mass ejection streaking off the sun. Hoping that someone on our path gets to see that today. If you do, be sure to send us the photos. We'd love to see that as well. One other cool feature about this tool too is you can see the actual path that the moon is going to be taking across the sun. And all of this plays in real time if you time it up well. And so you can actually see, if I go to our live moment here, this is actually playing as what we're expecting in real time, the movement of the moon across the sun. Carbondale just had a little crescent there, and you can see that shadow is really closing in on them very quickly. Let me turn off that 2017 path and zoom in a bit here. You see there, nearing totality in just a few moments, and their weather is looking great. We've been checking in with them all morning and afternoon. 27% cloud cover. That time of totality is coming up at 1:59:15. Really excited. And then it's going to be kind of bang bang for a while afterwards for a lot of our sites. We're going to be moving on to Indianapolis, all the way up to our final target in Holton, Maine. There is a lot coming up. And even again, still, if you're outside of that path of totality, have your glasses at the ready to be able to observe that partial eclipse. This is going to be going on for a while. But for now, let's take a look at Carbondale and see up close what it's looking like. How is it looking over there in Carbondale?
Couple more minutes.
Well, the crowds are going nuts here in Carbondale at SIU at Saluki Stadium. Bob Baer is with us, and Bob, it's amazing. I'm afraid to look up. I know it's not quite ready yet, but tell us, what do you expect here for the eclipse today? Good weather.
It's good weather right now. We have high clouds, so totality is going to look just a little bit fuzzy to us, a little bit hazy, but we are moments away from seeing the diamond ring here. This is awesome.
Oh, I thought we saw it.
I think we got about 1 minute.
Okay, 1 minute away. Now, today we're having longer totality. So are you feeling the temperature change? Because I'm already feeling the temperature drop.
I felt the temperature dropping about 20 minutes ago even, and the wind picking up a little bit. And I think, yeah, we have 4 minutes and 9 seconds here, so it'll continue to get cooler. And we got a lot to look at in the sky.
I'm very excited. I'm looking up when I can.
Oh, it's so close.
It's getting very dark right now. Very dark. You can see the shadow going across.
This is the start of it. It's dark over here. It's light over there.
This is
The shadow's
amazing.
coming.
Crowds are going nuts. We're about to get word that we're at
That's
totality.
Venus.
Oh, you can see the planets. The crowds are going nuts. This is crazy. Bob,
Oh my
this is
God.
amazing.
Here we go.
Don't look at the
Close.
sun yet. It's
Real
not quite
close.
totality, but you can still see some of the planets right away.
Very close. You got about 15
And the crowd
seconds.
is very
oh,
happy.
shadow bands.
Oh, total darkness here. This is incredible. Oh, wow.
There it is.
There
Diamond
it is.
ring.
Diamond ring.
Diamond
wow,
ring.
that's amazing.
Hold
It's
the
amazing.
filter.
That is awesome. Look at that. Oh, and Bob, that's amazing.
Wow. Jupiter.
Complete totality. I see Jupiter.
Oh my gosh, that is gorgeous.
Wow, this is amazing, Bob.
Wow, that is huge. So we have some prominences. I think we want to go look through the
Yeah,
scope.
go
Blair.
through, look through the scope. I'm going to walk over with you as you talk through the scope. We are right here at one of the telescopes that we have positioned here. Bob is
Wow.
looking through with the naked eye and
So you got
going to give us some
prominences.
feedback on that.
We
Maybe
gotta-
maybe
yeah.
some prominences we're seeing.
We
What's
got prominences
amazing
all
is how
around
dark
it.
it is compared to 2017. Much darker, a lot more astronomical features. We have seen Jupiter, and I believe what planet is that, Bob?
That's Venus
to the right. That's
I
the Venus.
Can't quite see Mercury. I think it's obscured by those light clouds.
Yeah,
up
light
there.
clouds.
But 360-degree sunset around us.
This is amazing.
It's going to get darker.
It's going to get darker.
It's going to get darker.
Wow,
Yeah, we're
this is
not-
already
we
pretty
are-
dark.
We are not in the middle of the shadow quite yet.
Wow.
Did you see it?
Yeah, timer started.
Okay, 2:46 to go. Okay.
Yeah.
All right, so we're getting some live data from the team
it.
here. I tell you, it's really impressive, Bob, because
Oh my gosh,
Oh,
it's getting better. See that prominence at the
yes,
bottom
at
of
the
it?
bottom, there's a prominence. I see it.
Wow. I keep looking
I
for
can't believe the
Mercury, so
clarity. That it's so much
it's-
darker than 2017.
It's gorgeous. And what's awesome, we have 6 telescopes running back here,
That's
capturing
awesome.
data, streaming this.
And that's a big important part here. This is not just capturing image to share with people watching the show. You are actually capturing scientific data that can be used by scientists everywhere.
We are, and we've seen totality across North America so far in Mazatlan. Now we're experiencing it ourselves, and we'll experience it after this on the Jumbotron
It's
from
like-
the other dev sites.
It's like the most amazing Eclipse train you could ever ride on.
Wow. This is a bit better than 2017.
Without a doubt, without a doubt.
No cloud.
And you know what's interesting is the crowd is quieting down. They seem to be experiencing the moment, taking it
Yeah.
all in. A really special moment here.
Look at that. So we must be getting close to the center. Where are we at? 2 minutes? So 1 minute, 30 seconds. The corona's looking brighter because
Yes.
our eyes are adjusting now.
I mean, that is amazing, Bob. And how much corona you see. I mean, like
A
just
lot.
last time I
That's
didn't
like-
see that much.
Visually, oh, there goes a bat. See a bat flying over the crowd.
Oh yeah, we talked about the animals. Now
Yeah.
we see them becoming active.
We found a Luna moth earlier as
Wow.
well. But
Wow.
that corona is about 4 times the diameter of the sun. That is massive.
That is amazing, Bob. And I'm really curious
1
about
minute?
that
Okay.
prominence at the bottom.
Have you looked yet, Blair? You
No,
have
I
to look.
haven't. I haven't looked.
So take a look. So Blair's looking through the scope now.
Oh my
at
goodness!
Totality.
No, that one right at the bottom is significant, Bob. It looks like a coronal mass ejection, but don't fact check me on that because I'm just a novice. But there's actually 2 on the Bob. You got to look at that. There's 2.
let's take a look. We got-
Look at the
30 seconds. William.
30
hop on
seconds
as
left
soon
in
as Franklin's
totality.
done.
William, jump in there. Take a look. It's great
It's
because
close.
we have
Oh, it's getting-
telescopes out here for people to look at and actually see total
you can
eclipse
see more
through it.
corona.
And
We're getting close.
I don't know what you guys
Time?
are seeing on television, but
10 seconds. We got to cut it off.
okay, all right, here we go. 10 seconds before we
cap
need to
on.
put our glasses back on.
Okay.
Oh, sorry.
You're good. You're good. We put the cap back on the telescope to make sure nobody looks.
What an amazing
Too
event,
late.
Bob. There's
we
the
go.
diamond ring. There's the
Nice.
second one. Oh, snap. Oh, that's amazing. It's like it was scheduled.
Yeah, somebody had the timing right here.
Oh,
my
man,
gosh.
that's amazing.
We will see shadow bands again here.
You hear the crowd. Everybody's excited.
That's
there
awesome.
we go. What an amazing moment here at Saluki
Wow.
Stadium
Oh my gosh.
with Bob Bear and 10,000 fans, all loving every moment of it. Bob, some final words.
Well, I think we just had an eagle fly over.
Okay, so
But incredible.
well, that's
So
one of those things you said. We saw animal reaction. We heard it. We felt it.
It was wonderful. So we got to keep an eye out for shadow bands. We're going to see them again in about 1 minute on the ground here.
Okay, so we'll keep looking for those shadow bands on the ground, but I got to tell you guys back at the studio, I know you guys have seen eclipses already. There's still some to come, but what an amazing moment. Back to you guys. Good weather all the way to the end.
Thank you, Blair. We are in Indianapolis. We are almost at totality. With me, I have Nikki Rail, the Associate Director for Flight Programs for the Heliophysics Division, and Denise Hill, NASA's Outreach and Communications Lead for the NASA Heliophysics Division. You guys, let's get our glasses on. And you can hear the crowds start to roar as everyone gets on their glasses. We are so, so close. Ladies, what are we seeing right now?
I mean, just the ambiance of this moment. It is beautiful. We're just seeing a really small crescent, but the light all around us, it's so dusky
And I'm
just odd.
It is. I'm feeling a temperature drop already, which I can't believe. It's feeling cooler. The crowd is starting to go wild.
yeah.
We're still seeing them
Here we
crescent.
go. Here we go.
Getting
All
close.
right.
We are so
All right. And
close.
the best soundtrack you could possibly ask for in the background here.
Absolutely. Oh, we're so close.
Okay, just a little bit left, and you can really hear the crowd
Oh,
taking
here we
over.
go.
They
Starting to go
cannot be
wild.
more
Here we
excited.
go. Yeah, here we go.
There we go. We're so
All right,
close.
Here we go. Almost.
Almost.
There.
We are so, so close. And we.
Oh my gosh, there's that bright diamond ring.
Here.
All right. Oh, wow.
Here we
Look at
are.
that.
There it
I can
is.
see the.
Yes.
Oh my gosh. I can actually visualize the corona. I've always wanted to see that.
Wow. Look at
Wow.
that. Fantastic.
Oh my God, it's gorgeous.
Oh
That
my
is
gosh.
absolutely
An incredible sight.
amazing.
And dark.
Wow.
Wow.
Look at how dark it is. Oh my gosh.
Whoa.
And you can really see those streamers coming out right now. I'm seeing some bright lights around where we're seeing cratering, and I can see those streamers coming out of the corona.
And are those Bailey's beads? Are we seeing any Bailey's beads?
We were seeing some Bailey's beads. They're transitioning out a little bit, but yes, those bright light where the sunlight is shining through craters on the moon, mountains and
Wow.
craters. And look at those streamers of the corona. It is putting on a
Holy
show.
moly.
And it is dark.
Holy moly.
It is,
It is-
dark.
I gotta take a peek at the crowd right now.
Oh, look at the crowd.
Oh
The
my
crowd
gosh.
is
Oh
absolutely
my gosh.
going wild. Everyone's got their phone out. It is now safe to look at the eclipse without your glasses.
Wow.
What an amazing sight. Folks, we've got 4 minutes here, a little under 4 minutes to enjoy this.
Wow.
And if you were in an open field right now, you'd be able to see a sunset, a 360-degree sunset all
Yes.
around us.
Yes,
And you
I
can see a
can
little bit of
see
that
You
it.
now.
can see the light around us a little bit.
Yes.
I have to say, this is my first total eclipse, Denise.
This is my first total
Incredible to see it.
totality.
Wow.
This is a bucket list moment for me.
This is incredible. Really a once in a lifetime, unless you're an eclipse chaser, which I'm considering it.
I might
I'm
become one after
considering
this.
it.
I quit my job.
Wow,
Oh my
fantastic.
gosh.
Oh
We
my
spent
gosh.
so long trying to see that corona, and to see it with my eyes.
Yes.
Your own eyes. Wow, just gorgeous.
I'm just in
Oh,
awe of
yes.
being this person on this rock moving around the sun.
Yes.
I can't even believe it right now.
Yeah, and to share this moment together with 50, 60,000 people all looking up at the moon and the sun all at once. It's just an incredible experience for all the folks here in Indy and for all the folks watching. I hope you can take, the amazing energy and excitement from this crowd. What a special moment for the United States.
Wow.
Oh my gosh, did you hear that? Look at this and everybody.
Oh, there
oh
we
my
go, the
goodness.
crowds.
Wow.
Wow. Okay, so I think we're seeing Yep, those beautiful prominences.
The Corona is just putting on such a show right now. It's got my
Yes.
full attention.
Wow.
That's all I can watch.
Holy cow. We've got some very appropriate music on, going on in the background here.
This is the best version of getting mooned that I have ever experienced in my life.
Don't strain your eyes.
Oh,
Wow.
I am just in awe. There just aren't the right words to describe this.
I'm just noticing it feels so strange to me right now. Like I feel the hair on my arm standing up. I feel like it's nighttime and what am I doing? And it was daytime.
And actually, folks, we're starting to get some nighttime insects coming out.
Yes, we're starting to see bugs.
Yeah, we are seeing bugs in light. It's hard to hear them over the crowd, but I can definitely see them flying.
Yes, I think the animals are a little bit confused. Nikki, while I have you, we've got a lot of programs at NASA looking at the sun. No eclipse glasses required. As the Associate Director of Flight Programs, tell me, what can we expect NASA to be sending to the sun in the next few years?
We are so lucky in the midst of this incredible time of solar max. We're getting ready to... I'm seeing a diamond ring right now.
The diamond ring. Take a look. Put your glasses back on. Be safe. That is the diamond ring, folks. Wow, spectacular. Oh my gosh. You can even hear fireworks in the distance.
Yes.
Oh my gosh. And the light is already starting to change.
It really is.
You can
wow.
And the crowd
getting fired up. You can hear the crowd just loving every second of it.
Oh, what a moment. I love those fireworks. Indianapolis is really pulling out all of the stops, and we love them for it. I also want to take a moment here to thank our two telescope operators, John and Dana, who have been providing these telescope views for us there from Ball State University. Thank you very much to John and Dana. All right.
It's like somebody flipped the lights back on.
It's really
It's
like a light switch flip.
This is so crazy.
And I can feel it warming up already.
Yes.
Wow.
This is so amazing.
Incredible. Well, this is an incredible moment and an incredible moment for the Helio Big Year. Ladies, thank you so much for joining us. This has been fantastic.
Thank you for having me and sharing
I'm
this.
so excited to be here and to see this incredible sight.
Absolutely. Megan and Sarah, back to you.
Oh, that was so fun to experience, and I can't wait for us to do it now. Take a look at this drone shot where you can see it definitely got noticeably darker. We feel it here. It's colder. The crowd is cheering now. They're ready for totality here in Cleveland, Ohio. We are less than 3 minutes away, 2 minutes and 18 seconds away from totality here in Cleveland, Ohio. The crowd over here to our right
really
going
feel the
crazy,
excitement.
feeling the excitement. I'm ready for this. How are you?
Yeah, it's super cool. It's all of a sudden it's really getting dark and you're starting to feel it.
Yeah,
so cool.
It's like they just dimmed it out. Now it's like night. This happened within the last couple of seconds. But let's take a look around, because obviously we're not the only ones enjoying the total solar eclipse today. We have some we have some eclipse viewing events that we've seen around the country. So why don't we take a look at some of those? Wow, oh my gosh, so this is
cool.
Times Square. That's the NASDAQ tower, and they are taking our feed live right now, and we're seeing
awesome.
Cleveland, Ohio sun.
They're only going to get a partial eclipse today, but they get to watch our eclipse with us. So.
Yeah, I'm really glad that they can do that. Wow, look, that sliver of a crescent just left. It's actually perfect on that building.
It's beautiful.
The shape of that building, right? And we can see some people in the foreground taking a look, stopping to watch. It's hard to stop in Times Square, right? But they're stopping to take a look at this with us.
Beautiful.
Oh, awesome. So this is just next to us. This is Progressive Field here in Cleveland, Ohio. So the Guardians have their opening day today, and the first pitch is like after 5 o'clock. But as you can see, they've opened up the stadium, and people are in there to enjoy the
big crowd in
eclipse.
there to watch that. That's great.
Yeah, you can, oh my gosh, it just got darker here.
Yes.
Oh my gosh, that's so interesting. And then Mentor Civic Amphitheater, again, the field starting to fill, and everybody looking up at the sky for their opportunity to see today's solar eclipse. This is us back here in Cleveland. Everybody looking up at the sky. We have 30 seconds until totality here in Cleveland, Ohio. Oh my God, I'm I have goosebumps everywhere. Everybody's starting to cheer. I might cry. I kind of feel like crying. This is so cool to see. It's getting so dark so fast.
Wow, it's like night just descended on us.
And look at the crescent slowly disappearing. Crowds cheering here. Cell phones up, cameras up. 5, 4, 3, 2, 1. And totality. Totality, everyone.
Oh my God. Oh wow. Oh my God.
I was so nervous.
Wow. I know, I wasn't sure because we had some high clouds, but oh my goodness, you can see that corona extending out. Oh wow.
Yeah, the clouds were really bothering me and really scaring me. It did get very cloudy here in the last hour and a half, but we have a great view here in Cleveland, Ohio.
Yes.
Wow, look at the corona.
You can hear the crowd. Wow, everybody's got their phones out.
Oh my gosh.
Wow. You know, I saw pictures of what the shape of the corona might look like from our NASA scientists, and it looks exactly like they predicted.
Oh my gosh. Oh, and you can see Jupiter and Venus.
Oh yeah, look at that.
So Jupiter's to the upper left of the eclipse that we're watching, and just to the right of it is Venus.
Yes. Oh, and I see some of those pink protuberances we've been talking about all day.
Wow.
Beautiful.
And again, all around us you see light, but just at the top where we are.
360 sunsets.
Exactly, exactly. Yes, Indianapolis had described that as well.
Woo!
We have totality here for 3 minutes and 50 seconds.
That is such a luxurious amount of time. I saw the 2017, I think we only had about 2 minutes. So.
And why is that? Why does the length of totality differ?
Oh yeah, well, because sometimes the moon is a little closer, a little further away. Its orbit's elliptical. And so when it's further away, it looks smaller in the sky, but when it's closer, it looks bigger, and so we get a little bit more extra time.
Look at the prominence. You can see it on the bottom. On the bottom there.
So pretty.
Wow.
It's like bright pink.
That is insane that you can see it from there. From here.
Yes.
Just like the power of our sun. I'm truly in awe right now. And cold. I'm in awe and cold.
It did drop.
It is noticeably
10
colder.
degrees. It's like, yes.
Yes. Looking around to the crowd. A lot of people videotaping it, trying to take photos.
It's the lovely backdrop of the Cleveland skyline.
Yeah, that's beautiful. We have the stadium right next to us. Oh my gosh. And again, thanking the Great Lakes Science Center and NASA for hosting this event here in downtown Cleveland, Ohio.
And it's great to sort of join humanity to all come together at once and experience this together with such a great
Oh,
group
look at the
of
screen
folks.
right now. Here's a shot of the skyline.
Oh,
wow, the sky looks on fire. Beautiful. A lot of excitement still here in the crowd. Sarah's just taking it all in. Sarah, you're supposed to be commentating. You're supposed to be saying.
It's so beautiful.
So you can tell that we have some cloud cover, right? It's kind of hazy here, but still.
It is, yeah, some high clouds. I was worried about it, but we can still really see, have a pretty good view here.
Wow. And again, this is so rare for people here in Cleveland to see a total solar eclipse. The last time was 1806.
Yes.
The next time, guys, 2444. That is incredible.
I hope everybody took the time to come outside and witness this today.
Oh my gosh. You can still see that prominence. Again, talk to us about what a prominence is.
Yeah, so that pink color comes from the helium in the sort of outer atmosphere of the sun there. Oh, it's beautiful.
And it gives off that pink glow.
Yeah.
Wow. Totality ending here. Wow, there's the diamond ring. Oh!
Time to get your glasses back out.
Time to put your glasses back on, everyone. That's your cue. Glasses back on.
We get
wow.
that diamond ring.
Wow.
Beautiful.
What an amazing experience. My first total solar eclipse.
Yes.
Let's see what they think about this in Niagara with Daryl Nail.
Over the entire area. You can hear the crowd erupting at various moments when the eclipse has been seen, but we are under pretty cloudy conditions, and David Sheeny is with us. He's a program executive with the Heliophysics Division. David, this is a challenging situation to be in order to try to see this eclipse. We've seen glimpses.
We have seen glimpses. So we're basically spending our time staring at the sky, hoping for a little bit of a glimpse of what would be a totality. So right now, the sky has just completely gone dark. You see all the lights, basically, everybody's cameras and everything else are all making it lighter. And it's gotten significantly colder as well, just over the last several minutes.
And it's fascinating to see it go night like this. We've been listening to everybody across the country enjoying totality and seeing it clear. That's not the experience we're having here. In fact, it's so cloudy that our telescope operator, Jessica Bellina, who's working very hard to try to get a lock on it, has not been able to get that telescope feed dialed in because she has to have a view of the sun in order to see it. So we don't have a feed for you from Niagara. What we have is just every once in a while you'll hear part of the crowd, only part of the crowd will cheer because I guess they kind of have an angle through the clouds to see just a little bit.
Yeah, and the clouds have really only cleared out enough occasionally to even need eclipse glasses. So for the most part, you have a thick enough layer of clouds that you can see the eclipse without them, and it's just fine. So a lot of us have been able to just take regular pictures with our cameras.
Let's take a look and just kind of enjoy the moment of darkness that we're in now. People have come from all over the world to be here.
You can see some. It looks like it's a little bit lighter up there. Our spotlights are blinding these guys. Can we turn the spotlights down? So there, look, you got a little bit of eclipse right there with people watching. So we're just catching little glimpses of things as we look up into the sky. So this might not be as exciting as some, but this is what we get. We're just hoping to have a little bit of a glimpse.
Well, we've got 3 minutes and 29 seconds for it to happen. We're already a minute or so in.
Right.
We heard there's going to be skydivers that are going to jump out. Probably hard to see them.
Yeah, I don't know that we'll ever get to see the skydivers. You can't see any of Niagara Falls really. It's basically all like as if it was night for us here. You can start to see some of the light come in from the other side.
So we're taking now a view of Tupper Lake, New York. That's
oh, look, there you go.
Oh, hey,
we got totality right there. We're getting totality right now that we can see.
There it is.
We just got a really nice clear spot right there. So
wow,
got a little bit of hole through the clouds so everybody could see.
Just opened up. And now that was the roar from the crowd that you just heard, and just as soon as it showed.
So yeah, we're continuing to watch the totality that we're getting right now. You can see a little bit of hint on the side as it's shining through.
Down there, duck down.
Yep.
Jessica,
so here we go. We have another view, a little bit, another little view right here.
No.
As it's starting to peek out around.
Oh, there it is.
So we're getting starting to peek out just around right there. Yep.
Well, totality is complete.
Yeah. Well, that was a fun experience to watch and hope for, like just everybody else around here, hoping for a view. And we got it.
That was a unique experience. Bring the lights up. And suddenly night is turning into light and day.
Yeah, we're getting some light again. Oh, although that's a lot of light.
I was worried there for a second that we weren't going to get anything. David Sheeny, thank you so much for joining us. Appreciate you sharing this experience. I was really worried that we were going to see something. Fortunately for everybody here in Niagara Falls, we got to see a little bit of the eclipse. And
yes, we did.
That
was
great. Some of the cheering now. Thank you very much.
All right, you're welcome.
As we take a look around the falls, and people have not moved. They are still looking up, enjoying the partial eclipse now. We're going to bring in Jeremy Hansen. He is a Canadian Space Agency astronaut who has been at the falls with us for the past few days. And Jeremy, You're going to be on Artemis 2, of course, the mission. We'll talk a little bit about that.
I'm going to be looking over your shoulder here, Daryl.
Hey,
Cool
make sure you put on your glasses.
Well, we're still pretty safe. We got a lot of cloud cover, but
That's true.
That was actually, I think, exceeded expectations.
Well, I mean, when your expectations start off with just clouds everywhere, and I didn't think we were going to get anything. How did you feel when it finally poked through?
I felt like success because we all really wanted to see it in totality, and we might have only saw it for 5 seconds, but we did get to see it, and we could see the corona, and that was just very special for me. So I really like that. And then when it passed totality, it was like this amazing, hopefully the camera captured it, but just like that amazing sunrise just coming across the clouds. Actually, the clouds kind of made a nice backdrop for it, so that was pretty special.
That was very unique, very special. I'm so glad and a little relieved that we got to see a little bit of it. That was the moon passing in front of the sun. You're going around the moon in September of 2025, currently scheduled for that. You'll be the first Canadian to do so. You just saw a real special moment. That's another one. What are your thoughts on getting ready to take that big trip?
You can imagine I have a lot of thoughts about Artemis 2 and what Reed, Christina, Victor, and I are getting ready to undertake. But if I have to boil it down, a lot of it comes down to pride. I'm really proud of humanity for taking on these big challenges. I'm really proud of the United States for their leadership, for creating this opportunity where other countries can express our genius, bring real contributions to the program. And now Canada is going to be the second country in the world to send a human into deep space. And it's got nothing to do with me. It has to do with the genius that the world is sharing. I just love that.
That's amazing. Want to mention real quick, we are in full totality up at Tupper Lake, New York, not far from here in northeastern New York. We're here in western New York where light is continuing to shine and get a little bit brighter. It really is special, and we really felt that in the 4 days that you were here interacting with the public. Was that your sense?
There's a lot of excitement around this celestial event that's happening and around space exploration in general, which I find really uplifting. I don't think space exploration solves all the problems or challenges of the world, but I do believe it is one of the pillars of those solutions. It doesn't matter what problem you're looking at, space plays a role. And I love it when I see our youth getting fired up about, asking me, how do I work at NASA? How do I work at the Canadian Space Agency? We're on the US side here, but I've had some Canadians come up to me. It's just something that brings us together, this, the spirit of humanity. Just like this experience we're having here, it's a very, it feels like community. We're all out here, just humans, just being humans and sharing something special.
And sharing it together was really neat, that communal part that you talk about. Like, I felt a little bit of a bond with everybody here now. Yeah. You as well. Appreciated seeing you and having dinner over the past few nights. Just happened to work out coincidentally. Yeah. Really enjoyed the time. Great words today, and we will all be rooting you on for your mission coming up in September of next year. So good luck. Be safe. We'll be rooting you and your crew on. Thank you, Jeremy.
Yeah, no, we'll take it. I appreciate that. And I don't know if you saw it when you're on camera because you were busy, but the birds, they just went nuts in totality. Did you see that?
No, I didn't see it.
They're all up here. They came out of the woodwork. I mean, there's been birds all day, but it was sort of like birds filling the sky. I thought that was really neat to see. Anyway, thanks for having me today. It's a pleasure to be here.
Thank you fill that out in your citizen science journal. Make sure you put that in there because we're doing that. All right, thank you, Jeremy. And I just want to say thank you also to New York State Parks, Niagara Falls specifically. We couldn't have done this without you. So thank you very much. Definitely. We're going to throw it now to Kennedy Space Center where James Traley is tracking totality at Tupper Lake. James?
That's right, Daryl. Yeah, we are still in totality in Tupper Lake. We are nearing the end of our eclipse across North America. You can see our last target of the day, Holton, Maine, is all the way up here, almost off your screen. This speed of the eclipse shadow is moving so quickly across. The ground speed is about 2,000 miles per hour, so that is a fast clip. If you're in the path of totality, really take full advantage of those few fleeting moments to observe this moment. If you're not in that path of totality, or if you missed it, hopefully you didn't miss it because we've been tracking it all day here showing you. If you did miss it, I'm going to zoom way out here and show you what to keep an eye out for in the future. So this is going to be the eclipse path in 2045. We're going to come through parts of Montana into North Dakota in 2044. 2045 is the next big eclipse across America. That's actually going to come, oops, I didn't draw here, there we go. that's going to come all the way from California into parts of Florida there. That is in 2045, so a long time to wait. So really take full advantage of those fleeting moments to be able to observe this moment. I'm going to click on Burlington here, who are also in that path of totality, experiencing that right now too. So just an incredible moment to really see all of this. And Tupper Lake, again, they're still, I think, experiencing that last fleeting moment there. That is just moving off. You can see that is officially now moved off Tupper Lake. Really a fantastic shot. They have that now, that diamond ring effect, that really beautiful shot there. This is, again, such a quick moment, and this doesn't happen very often. It's really a once-in-a-lifetime moment, so take full advantage of this. You can see just how close we are now to Holton, Maine, who are our last stop of the day on our NASA coverage here. This is then going to continue on into parts of Canada and beyond. Holton, Maine, they had some snow the past couple days. It seems to have cleared up quite a bit more for them. Really hoping that that holds out for them. They are expecting a duration of 3 minutes and 20 seconds to be able to observe that totality at 3:32:05 local time. Really excited to see that view. You see that shadow creeping so quickly up to them up there. So let's check in with Angelique, who is up there in Holton, Maine. Hopefully it's beautiful weather for you. How's it looking up there, Angelique?
James, it is looking awesome up here. We are just a few minutes away from totality. Can hear people announcing it in the back, and people are getting excited, as am I. And here to share in all of that excitement with us is actually Dr. Eric Smith, the program scientist for the James Webb Space Telescope. Eric, it's so great to have you here.
Oh, it's great to be here, Angelique. This is really exciting.
Eric, is this your first eclipse?
This is the first totality I'm going to see, so I am super psyched, and I am delighted to be here in Maine to experience it.
Yes, and so we've actually been kind of watching as it slowly gets closer and closer, right? And what are we? We're starting to feel it getting kind of cooler. We're seeing the shadows change.
Yeah, we're seeing the light is definitely different from when the sun sets and the shadows get a little diffuse. Here they're still sharp, but the light is diminishing. Your brain tells it something different is happening.
Something is definitely up. So speaking of up, that's where the James Webb Space Telescope is. And what's interesting about the telescope is that it actually can't look directly at the sun, just like we can't.
Yeah.
Can you tell me a little bit more about why that is?
Sure. We designed Webb to look for very faint things in the distant universe, so it's very sensitive for very faint things. Of course, the sun is very bright, and so we had to make sure that it could never look at the sun. We use solar power to power the spacecraft, but the telescope can't look at the sun.
That makes a lot of sense. Now, as it's starting to get a little bit closer to all of the cool phenomenon, the Bailey's beads, the diamond, let's go ahead and put on our glasses.
All right.
So that we can look up and continue chatting. Wow.
Oh, just a little tiny
Just a little bit left. That is incredible. Wow. So, Eric, I have a couple more questions for you. Another thing that I was wondering about is how we can use actually eclipses to study exoplanets, which are planets outside of our solar system, using, I think, the transit method. Is that what that's called?
Yeah. Right now, during an eclipse, the moon...
Sorry, you can hear everybody getting excited. We're getting very close to totality here.
The moon is transiting in front of the sun just the way planets that orbit around other stars transit in front of the star. So Webb can look at those exoplanets and use the transit just like we're staring up at the moon transiting the sun.
Gotcha. And so a transit is, like you said, literally just when something crosses in front of something else. That's
right,
transit.
Yeah.
Okay. Very cool. So throughout the broadcast, we've actually been able to see the eclipse through different telescope feeds. Can you tell me a little bit about what the difference is between, actually, we're going to go ahead.
Oh, here we go.
We're getting really close. Oh my gosh, it looks like just a few more seconds until we are in complete totality. Oh my gosh.
Oh.
5, 4, 3, here we
2,
go.
1.
You can hear everybody cheering. This is incredible. So let's go ahead and take off our glasses. We are in totality now.
Oh, you can see the coronal spikes. Amazing.
That is
beautiful.
Incredible.
You can see a planet in the sky that you couldn't see before.
Oh, wow. And I think, is that one of the, oh gosh, the
there's some drone. There's a drone up there in the sky, too.
Oh, my goodness.
Oh, wow.
It's incredible. The rays that you can kind of just see coming off of the corona.
Yes, yeah. Stunningly beautiful.
Yeah, that's
Yeah.
got to be one of the most amazing things I've ever
And
seen.
you can see the gradation in the sky color
Yes.
down to the horizon,
Oh
too.
my goodness.
Yeah.
I am seeing a bit of that 360-degree sunset.
Yes, yeah.
That is really cool.
It's amazing. Even though we're in the total shadow
Right.
here, there's still the corona is still pretty bright.
It is incredibly bright.
You could read by the light of the corona.
I think I would have some trouble reading, but I probably could. I could technically read something. So, Eric. Oh, and actually, we have the International Space Station flying over right now. So they are actually seeing not one, but two views of the eclipse. They're able to see not just the moon passing in front of the sun, but they're also able to see the shadow of the moon passing over Earth, which is absolutely incredible. I mean, I can hardly imagine a view being better than the one we have right now, but if there is one, it's
probably on the space station.
It's from the space station for sure. Wow. So yes, they're able to take some pictures of that, and that is just incredible. Just incredible.
One of the things they told people to do if you're far away was to hear how nature changed, and it was interesting here. We're of course surrounded by a lot of people, just to hear their reaction when we went into totality.
It's true, the humans in nature have not gotten quieter, but louder, I would say. But I mean, you can definitely hear the loudness has a different kind of character to it. There's almost like a, I mean, I don't know if wonder has a sound, but I think this might be it. Yeah.
Hushed awe.
Yes, hushed awe. That's wonderful. And I can see just one little red, I guess, like protrusion coming down
little
there.
red spots almost. I noticed those too.
That's cool. Now there are two.
Yeah.
Wow. That is just so cool.
Yeah, I like the 360 sunset. It's a little hard to see behind us, but it's.
Oh, we've got at least one or two drones.
Yeah, some. Our robot overlords.
Of course. And so, Eric, I know that, I mean, clearly with the drones, people are starting to get involved in the eclipse, and I know that there are lots of ways that people can actually get involved. One of those ways is with citizen science.
Right.
Do you mind talking about some of those opportunities, how people can actually...
Sure. We had citizen science programs where people could use their cell phones to take pictures during the eclipse. And
we're getting ready to come out of totality. We're just putting our glasses on.
And here we go. Oh, there it is. Oh, it's peeking out. Oh.
Everybody is cheering. We have just made it to the end of totality. We're starting to see the sun just peeking back
and it's
out
amazing.
again.
Now just look at the ground, how much brighter it's gotten.
It is
all of a
already
sudden.
so much brighter. That is so wild. That was probably one of the most amazing but also fastest 3 minutes of my life.
Yeah.
I wish I could do it all again.
Yeah.
All right, well, that was incredible. Incredible to get to experience that here in Holton. Thanks so much to the city of Holton. And also thank you so much, Dr. Smith, for coming out and hanging out with us and experiencing this wonderful event.
Oh, it was my pleasure, and congratulations to the city of Holton here for doing such an amazing job covering the eclipse. It was amazing.
I mean,
well orchestrated.
Above and beyond. Yeah. And I want to say, of course, a special thank you to photographer Dave Bowman, who has been giving us these incredible images from the telescope feed. And we're going to enjoy as the rest of the eclipse kind of ends here, going back in the direction that it came. And with that, we're going to send it back over to you, Megan.
Alrighty. Thanks, Angelique. So, Gina, I mean, what do you think? Like, we literally have just watched the eclipse travel, what, about 2,600 miles? It's
going across
Mexico to Maine.
Yes.
In like, what, about 88 minutes?
That's right. It's
so
fine.
fast.
That 1,900 miles per hour that the shadow is traveling.
I mean, did you have a favorite location?
For me, I think between Russellville and Dallas, just getting to hear some of my colleagues and their excitement too, it was amazing.
Oh my goodness, yeah, no. So, I don't know, I have to be a little bit biased. We did have some cloud cover here.
We did.
But to see it with your real eyes was just...
And we had that moment, which was...
We did, yes. It was amazing. And so it's really cool too, just to think about how millions of us now have this shared moment of what could be a once-in-a-lifetime event.
It's true.
And so, folks, we have time for some more questions from our viewers. And again, we have another great question from Mackenzie, who's in the 3rd grade.
Okay.
Let's roll it now.
name is Mackenzie. I am in 3rd grade. My question is, what is the difference between a lunar eclipse and a solar eclipse?
Thank you for that question, Mackenzie. Okay, let's talk about the difference between the eclipses. Now, the solar eclipse that we had today is when the moon crosses between the Earth and the sun. But we also get lunar eclipses, and a lunar eclipse occurs when the Earth crosses between the moon and the sun. So it's really about where the shadow's going. Today we have the moon shadow projecting on the Earth. During a lunar eclipse, we have the Earth shadow projecting onto the moon. So that's the main difference there.
That we just saw too, those incredible views from space,
That's
you
right,
know,
from
to
the
see
space
that
station.
second perspective view. And
Yep.
so I've got another question for you right now. It's going to be Eli on Reddit, who wants to know, there are quite a few solar eclipses in the world every few years. So why is this one scientifically interesting?
Okay, so yeah, we do get solar eclipses and lunar eclipses maybe 2 to 3 times a year. However, the total eclipse that happens today, total eclipses are about every 1.5 years. And that is a rare opportunity for us to look at the corona, study the corona in a way that we can't do during the other types of solar eclipses that we have. So
and during a solar maximum.
Exactly, during the solar maximum. So for this one particular, you know, we were talking about the solar activity that we were seeing on the limbs during the totality. Yeah, there's just a bunch going on today for this eclipse.
And so too, right now we've got another incredible view.
Oh, look at that.
These are live views from space, which is just mind-blowing in general. And now we're also to see the moon shadow across the Earth.
Wow.
It is just amazing. So, you know, Gina, too, thinking about how many people across North America today witnessed this one moment, it's a good reminder that humanity has been experiencing these eclipses for centuries. And, you know, there are different meanings for these events in different cultures. Let's check in with Joy in Dallas to learn more about indigenous astronomy. Joy.
Hi, and welcome back to Dallas, Texas. I'm with Dr. David Begay. He's an indigenous astronomer and also a member of the Navajo Nation. David, thank you so much for joining us. So when people think about science, they might be thinking of Western science. So David, how does that relate to indigenous science, and what did the total eclipse mean to the Navajo people?
I think the knowledge on the eclipse goes way back. From time immemorial, I'm told by my elders. And they knew that when you look at the sun directly, you can damage your eyes permanently. And so they knew that about the danger of looking at the eclipse with the naked eye. So people were encouraged to go inside to ensure that people weren't looking up, especially the kids. So it goes way back. And as far as eclipses, it's a time of renewal, the sun alignment with the moon and also the earth alignment. The whole cosmic cycle goes through a regeneration process. It revitalizes the process. And so it's a gift that goes on. For many years, over and over. It's a cycle. And as far as science goes, there's different definition of science.
Thank you, David.
Maybe we can cover it.
Thank you. It's been an honor chatting with you. So thank you to everyone here for joining us. Thank you for the Arboretum for hosting us. For this very, very magical moment. This has been an experience of a lifetime and one that I definitely won't forget. So let's head back to Tahira and Gina in Kerrville, Texas.
Thanks, Joy. We're joined now by Jamie Favors, the director of NASA's Space Weather Program, to tell us more about some cool science that launched today during the eclipse. Welcome, Jamie.
Thanks, Tahira.
Hey,
Thank you.
Jamie.
Hey, how are you?
Good. And so can you tell us, why did NASA launch rockets before, during, and after the eclipse today?
Sure, so it's really to capitalize on this really unique situation. You know, things like this happen every day, you know, going from daylight to, you know, sunset into, you know, darkness. but it happens so quickly that we can make these measurements one right after the next to really understand very precisely what's going on in the atmosphere. With sounding rockets, we can do that so quick back to back, the way we can't do with some of the really large rockets.
Okay, so Jamie, how high did the rockets actually go, and what's special about this area of the atmosphere?
Sure, and we just launched the second of those three just a few moments ago, and that's going pretty well so far. These particular rockets are getting about 250 miles above the surface, pretty close to right about where the International Space Station flies. And before you ask, everything's safe. We take care of the.
And it looks like we've got a playback of that right now.
Here
Oh,
we go.
wow.
Perfect.
Can you walk us through this?
Sure. So from Wallops Island out in Virginia, on the Virginia Space Coast. So these rockets have multiple stages to them. So you're seeing one stage burn for a few seconds, then that drops off, and then the next stage will light to eventually take it all the way up to about that 250-mile mark above the surface to make those measurements in the upper atmosphere.
Wow, that looks incredible.
Yeah.
Oh my gosh. Okay, and so what is that area of the atmosphere, and why do we care about it?
Yes, it's the upper part of our atmosphere. It's called the ionosphere. That's really from a perspective of heliophysics, where we really see a lot of that interaction with the sun and the earth. We care about it because that interaction can change the way our GPS signals work, our communication signals work, and even up a little bit higher, we start to see the influence of the sun actually causing the atmosphere to change its density in a way that can impact the way satellites orbit the Earth as well.
Sure. Okay. Great.
And so, Jimmy, today we've been doing this fun poll, to see who is Team Sun, Moon, and Earth. What team are you repping today?
Well, other than Team Science.
Don't choose the wrong answer.
Well, my bosses would make sure I go for Team Sun today for sure.
Oh, man. Okay. Well, thank you so much again. Thanks, Jamie. And folks, it is time now to say goodbye to our friend, James Traley, who has made sure we've known where and when to look up all day. James, thank you.
Yeah, thanks so much, Tahira. It's been fantastic tracking this eclipse across North America all afternoon with you. If you're still in the path of totality, you might be in a boat somewhere off the Canadian coast taking this all in. I hope you enjoy that view, that fleeting moment. We've made a big journey across. I can zoom out here on our Eclipse board. You can see we started all the way down here in Mazatlan, Mexico. We've trekked all the way across and are now, like I said, breezing past Canada now into the Atlantic Ocean. It's been fantastic to track this. And if I turn on the shadow of our penumbra, you can see this highlighted area. Anywhere in there is still experiencing a partial eclipse. So if you're in that partial eclipse area, be sure to have your eclipse glasses at the ready so you can take in that fleeting moment. We just went outside a few moments ago here at Kennedy Space Center to take it in. It's fantastic, beautiful view. It's really cool to see. You got like a little chunk out of the sun there for us here, only about 50% coverage, but still fantastic to see. So really, it's been phenomenal. We've lucked out in general with the weather all of today too. That was the biggest concern I had going into the day here. It's been beautiful views up and down here, and so really fantastic to see this. Really been a lot of fun tracking this with our Eclipse Explorer. A big thanks again to our scientific visualization studio for putting this tool together. But for now, back to you, Tahira.
And here with us now is NASA Chief Scientist, Dr. Kate Calvin. Kate, welcome.
Hi, Kate. Hi, nice to be here.
So happy to have you back here again. I know we had the pleasure of sharing the stage together for the annular eclipse.
Right.
Now, with today's total solar eclipse, can you tell our viewers what would you say is the #1 takeaway from today's events?
I would say the #1 takeaway is that our universe is beautiful and understandable. We all got to experience this together today. We could predict when it would happen, and we did a lot of science today.
That's great. So speaking of the science that was conducted, how does that fold into kind of the greater science that we're doing with NASA in the future?
Yeah, so we did a lot of science today, and a lot of it really complements science that we do all of the time. So one of the things we were really looking at today was the corona. The moon blocked out the sun so that we could see that part of the sun's atmosphere. But we also have a mission called Parker Solar Probe that's orbiting closer and closer to the sun so that we can study the corona with that. We were also looking a lot at how the eclipse affected Earth. So we had a citizen science project that looked at how the eclipse changed temperatures and clouds. We have a mission that launched 2 months ago that's studying clouds all the time, a mission called PACE.
Awesome.
It'll tell us more about oceans and atmosphere on here on Earth. And one of the other things we do is we develop instruments called a coronagraph. So the moon blocked out the sun today so that we could see that corona, but we can make an instrument that does that. And so we have an upcoming mission called Nancy Grace Roman that's going to block out the light of other stars so we can see what's flying in here around them.
Amazing.
So much going on for the sun at NASA, honestly.
Right.
And I understand that the Heliophysics Division has a big sun celebration going on right now, the Heliophysics Big Year. Kate, could you tell us how we could get involved in this and really just celebrate our star?
Yeah, this total solar eclipse was just one event in a series of this heliophysics big year, working towards Parker Solar Probe's closest approach to the sun. And we have a lot of activities where you can engage in our science and learn more about the sun. And if you want to know more, you can find us on social media at NASA Sun.
Fantastic.
Wonderful.
Thank you so much, Kate, for being here with us. It was really special to share this moment with you.
Thanks, Kate. It's nice to be here.
And Gina, this has been an honor. I mean, my goodness, to have the annular eclipse with you, then to share this total solar eclipse with you.
I know.
Thank you so much. And do you have any final thoughts?
You know, this was amazing. Annular was great, but to hear the energy here,
the total was
so
just
great
a whole
to be
nother
with
level.
Both of you, you know.
Yeah.
Once again, thank you for having me.
Absolutely. And you know, a big thank you to the city of Kerrville, Texas, the Parks and Rec team, and all the people that made today's incredible event possible. I also want to thank our telescope operator Catherine Troach, for those great views of totality here in Kerrville. Folks, that is a wrap from Kerrville, Texas. Back to you in Cleveland.
Thank you to Hira and Gina, and also Kate Calvin. And now check out who we have here at the host desk, the Pastronaut himself, Josh Dobbs, who just signed on as quarterback for the 49ers. How do you feel about that?
I feel good. I feel good. It's exciting times. Obviously, I spent a couple years here in Cleveland. Got a chance to have some fun over at NASA Glenn during my time here. So it's cool to be back and taking the Eclipse Fest here in Cleveland. But looking forward to the future in San Francisco. I know NASA's doing some great work out there on the West Coast, so we'll be able to stay tuned to that as well.
Yeah, so for people who don't know, the Pastronaut nickname comes from some incredible plays you had last year, and also you have a background here with us at NASA with some externships, but also you're an aerospace engineer. So how did it feel being back here specifically in Cleveland to watch the total solar eclipse?
It felt really good. You know, when this event was put on my radar about a year ago in last offseason, they're like, hey, like the eclipse is coming straight through Cleveland. We'd love to have you here. It's going to be a once-in-a-lifetime event to be able to experience it, especially right here on the beautiful Great Lakes, and obviously have some great weather today. So I marked on my calendar a year ago, and to make it back here and take it in, you know, and get a chance to hang out with the city I spent 2 years in, it's been great. I think like the biggest thing that I've enjoyed is just seeing the interest from the city of Cleveland and how many people traveled here to take in the event today, and to be able to then also go learn about the future of NASA and the future of space exploration as well at the same time. It's a once-in-a-lifetime opportunity to take it in, and it's been an honor to be here.
So, you know, Josh, NASA is really committed to inspiring the next generation through discovery. Do you think maybe we created a few new future scientists and engineers here today?
I think so. I think so. There's a wealth of youth walking around here and taking in not only obviously the blow-ups and the displays outside, but also the Great Lakes Science Center inside, and just seeing the history of the space program. I think that gives them perspective. And so that's just like NASA, that's been my approach. You know, I think the youth obviously is the next generation. They're going to have a tremendous impact on the world, and being able to inspire the youth out here and the youth across the country that if you have interest in STEM and also are really good at sports, you don't have to split your eggs into, you don't have to split up your eggs, right? Like you can go out, put all your eggs in both baskets and work hard to achieve those goals and dreams.
Now, Josh, we have time for one other question. It's the most important question we're going to ask you.
Okay.
Who was the star today? Was it the sun, the moon, or the earth? Say the right thing, Josh. Say the right thing.
Drum roll, drum roll. The star of the day was the moon. I gotta go with it. I gotta go with it. I gotta go with the moon.
I agree. I do. All right. Well, I appreciate your honesty. Right. I appreciate your honesty, and I really appreciate you being here. Thank you so much, Josh, and it was great to have you here with us.
Thank you guys for having me.
All right. So we talked about this controversial but friendly competition. So actually, we asked you guys to vote. We have the results of that poll right now. Let us bring it up. Whoa! Hey. All right. Congrats, Sarah. Come on. Congrats.
Thank you.
Team Earth, 26%. Team Sun, 26% as well. But Team Moon, 48%. Congrats, Team Moon.
Go
today.
Team Moon.
All right, again, thank you to everyone who participated. We were the real winners of today, though, those who got a show. But we're going to send it back over to Indianapolis for another really important interview.
Thanks, Megan. We are back here in Indianapolis. It has been an incredible day, and it is not over yet. With me, I have Jake Bleacher, the Chief Exploration Scientist for NASA. Jake, welcome.
I could not be happier to be here.
How was that eclipse for you, really quickly?
That was amazing. It's getting warm again. I still have my fleece on from when we were in totality.
That was incredible. Well, today has been all about the eclipse, all about the sun's light. And I want to pivot a little bit here because you're getting astronauts ready to go back to the moon, live and work there for the first time in 50 years. How the sunlight shines on the moon also very crucial to what we're trying to do there?
Yeah, well, just like this eclipse, it's the celestial dance between the sun, the earth, and the moon. And when we go to the moon, we'll actually have instances of eclipses where the Earth will eclipse the sun.
Wow.
So it's something to think about. But we're really interested in the lighting in the South Pole. Our Artemis 3 mission will land astronauts at the South Pole. And there, because the moon has almost no axial tilt, the sun is always right along the horizon.
Wow.
And so high peaks have sunlight more than normal amounts of time, and low depressions have almost no sunlight or never see the sun. And so we think there might actually be water trapped there.
Incredible. So one thing that we've talked a little bit about on the broadcast is space weather. And space weather is really important to understand, especially when it comes to the safety of our astronauts. Can you describe how the instruments Ursa and Hermes are actually helping keep our astronauts safe?
Yeah, Ursa and Hermes are payloads, science instruments that we'll have on our Gateway. Gateway is going to be a station, a research station that orbits the moon, and astronauts can stop there on their way to the surface of the moon. And these payloads, or these science instruments, will be there to basically detect what the solar weather is like, what we call space weather, so that radiation that our astronauts will live in when they're actually there. So understanding your weather is the best way to be prepared